Hey guys, I know I can't hear you or see you. We're just about to get started. Thank you for joining us.
Your team needs training in SOLIDWORKS to be effective, but you also have deadlines to meet. Scheduling them to be out of the office for days at a time to attend a training course, this just isn't an option. We hear you, and that's why we've created supported self-paced training courses. Like other online training courses, we've created on-demand web-based content for your engineers and designers to go through the material when it fits into their schedule. Quizzes are built into select lessons to test their skills and make sure they're learning the key concepts along the way, and a certification of completion is provided once they've met all requirements to complete the course, and you can verify they've learned the material. Self-paced sounds great, right? Well, here's the thing about self-paced training that nobody tells you. Less than 20% of all students who enroll in an online course actually finish it. Yeah, less than 20. And I'm not talking free courses. We're talking courses their employer has paid money for. But how can that be? Well, most online training providers only care that you sign up for the class. It's the student's fault if they don't finish it. This is where GoEngineer does things different. Our No Designer Left Behind goal means we want all of our students to finish the course and earn their certification. Because we want students to actually learn the material, we do a few extra things to ensure you'll get the most out of the training you paid for. For starters, students have 30 days to complete the course. This may sound backward, but the reasoning behind the time limit is based on research of completion rates. Put simply, we all tend to procrastinate and put things off, and the deadline is the most effective tool to ensure we finish something. Luckily, our training team is here to help. We monitor the progress of all students, and if we see someone is falling behind in training, we check in with them to make sure they stay on schedule. Speaking of support, students have access to our US-based team of certified SOLIDWORKS instructors. They're available 7 a.m. to 7 p.m. Central Time, Monday through Friday. They can be reached through our toll-free training support hotline, or students can schedule office hours at a time that works best for them. During these one-on-one meetings, our team will work with students through screen share sessions and walk them through any area of the course they're having trouble with or just need a little extra explanation. With our training support system, completion deadline, and learning verification built around our proven, effective training content, you can be confident your team is going to learn the skills they need to be productive in SOLIDWORKS. So if you're ready to get your team trained up, increase productivity, and minimize downtime, check out GoEngineer's supported self-paced training.
Thank you, everybody. Sorry if the audio didn't come through on that. I was trying to test that earlier. So if it looks like I don't know what I'm doing, I kind of don't. Anyways, my name is Ami Megani, and I'll be the presenter today. And first of all, I just wanted to thank you guys so much for joining us. There's a lot of things you could be doing right now. And I know it's a strange time, but you know, I appreciate you spending this hour with us. You could be working on your project or making sourdough bread or watching Tiger King, whatever it is. Oh yeah, and work. You could be doing work. Anyways, we've actually had an overwhelming response for this webinar. So because of that, we won't be able to answer questions live. However, I do have some colleagues backing me up on, you know, the Q&A and the chat. So we will definitely answer your questions. We'll probably distribute those answers after the webinar to all of you. And then this webinar is being recorded, so if you're in need of a nap or want to find out research where Carol Baskin's husband is or whatever, you can do that. So you'll find the recording of this on our YouTube channel. So give me just a moment. I've got to move some controls out of the way. Okay, so and then real quick, I just wanted to point you to one of our new web pages. It's called Design from Home. And just in this time where everybody is working from home, we just wanted to show you what your resources were. So you might have seen the video, Brian Childry's video on the self-paced training, which the one I just showed. So that's been overwhelmingly popular. So definitely check that out and see what that's about. There's also online training with a live instructor. So that's our online training. We've always had that. You've got an instructor on camera. You get a manual and a headset and participate in one of our training classes, just like you would in a classroom environment. We also talk about VPN considerations, you know, with your connection from home to networking or network license. And then if you are on a network license, it's really important that you know about license borrowing. This is good to know even if we were not in this quarantine era. I find that a lot of people I talk to don't know about this option. You can find out about temp licenses, virtual mentoring sessions, tech support. We've got free certification vouchers. That's a really good use of your time right now just to take some certifications. And then we've got virtual events like this one. And then we've also got some videos on 3D printer maintenance. And you can also access some free trials for CAM and Altair solutions. Okay. And just like I'm sitting here in my home, we have over 90 technical resources sitting in probably a more real office. But we are ready to help you. So please contact us if you need anything. Okay, a little bit about me. I have a mechanical engineering degree from UT in Austin, and I have some industry experience in sheet metal and injection molded plastics. Okay, so let's get started. So this is the agenda. You might have seen it in the invite, but we're going to talk about what defines a large assembly. We're going to go behind the scenes, what's actually happening when we open an assembly, different ways to open those, and then assembly tools to do a little troubleshooting. And then we'll talk about mates and best practices. We'll talk briefly about third-party data and importing and what you can do there. And then, you know, influence of detail, image quality, and some part file recommendations. Okay, so what is a large assembly? When I think of a large assembly, you know, this is what I'm envisioning. But you may be looking at that and saying, hey, like, you know, my assembly is like a fourth of that and we're having so many problems, you know, and that's okay. It's not necessarily, you know, a number of parts threshold or anything like that. Really, when we talk about large assemblies, we're kind of alluding to performance issues that you might be having because there's so much going on in your assembly. So contributors for these issues can be the complexity of the geometry, the machine hardware, the number of files. So anytime you're having performance issues or you're maxing out your resources, you might have seen you know, this in your taskbar. That's when we consider it a large assembly or that we need to take measures to improve the performance. Okay. So let's look under the hood. Let's see what it looks like when we open an assembly. So the first thing we talk about is, hey, is your machine good enough to operate a large assembly? Now it does depend on what's going on in the geometry and the part geometry. However, you know, we have some general recommendations for processor speed. We do recommend solid state drive. What I have posted here is the advanced system that we recommend. I've got a link. It's not a dynamic link for you, but I will send that to you guys after the webinar. But you can see what a basic, moderate, and advanced system looks like. But these are just kind of ballpark specs that we recommend. Okay, and then if you're in a position where you need to choose between processor speed or RAM, where are you going to invest your money? processor speed is better. You know, there are some multi-threading functions in SolidWorks, and opening files is one of them, but in general, processor speed is what you want to do. Most of the functions in SolidWorks are more of a serial process rather than a parallel process. So I generally recommend processor speed over RAM. And you can get more information in this link, and I'll send that out to you. Okay, so the other important thing to know is, where is this file? Where are you keeping this file? You know, the saving and opening location of your file has a huge impact on performance. It's the first question we ask in tech support. So local drive, network drive, does it matter? Yeah, heck yeah, it matters. So I'll show you some details about that and how you can determine how much that influences your assembly. And it's not just your top level assembly. You also need to know where you're pulling those referenced components. Hardware referenced files, you want to make sure all of those are as local as possible. Okay, so this is just a kind of a visual of what network, you know, travel of data looks like versus a local drive. So said another way, it would be like a direct flight versus a flight with multiple stops. Okay. If you're not sure how much this is impacting you, you can do a file pack and go. So do a file pack and go, bring it to your local machine. So an example of time savings, this isn't like high or low specs. This is kind of an average difference of time you'd see is from 8 minutes to 3 minutes, or 40 minutes to 12 minutes or something like that. So depending on what your assembly is, you might just do this test. This is kind of one of the first things we advise you to do is just see what that time difference is. Okay, so the first thing we do when we open the assembly is it shows you a preview of your assembly. You can actually disable that in your options. There's something, I didn't put a screenshot of it, but there's an option that says disable preview thumbnail. So that can lighten things. So you're seeing that the files are loading still. They haven't completely loaded. Your feature tree is blank, but you see that image. And so a lot of times people will say, well, I just saw it a second ago and now it's not there. Well, for some reason it can't find the files. It's lost its reference. So, so that's why you might see something like that. So you can disable this. It kind of takes a little more energy, a little performance, and that should help. Okay, so the first thing is it displays that kind of preview graphic, which is really just a snapshot of your assembly. And then it goes through your feature tree, your actual assembly hierarchy, and it opens the files one by one. Okay, so it's just the way it looks on your tree. It's going to interrogate that feature tree and access it one by one. Okay, then it's going to check for updates. All the files that were accessed, when were they last saved? If you're opening it in 2020 and they were last saved in 2017, it's going to consume some time to do that. And then it's going to rebuild what's necessary. So if a component has changed since you last opened it, even if someone else made that change, it has to go in and rebuild it, recognizes that something's changed. Okay, and then it calculates the mates, and then it generates the feature tree. So when you see the feature tree, you're almost at the end, and then it displays the final graphics. Okay, you can verify this through the file access log. There is no need for you to open the file access log ever. I just wanted to show you that it does open in this order. It will open the subassembly and then the parts in it. And then it goes to the next subassembly and the parts in that. Okay, so on paper, this is what it looks like. It opens the assembly, It loads all the reference parts and the sub-assemblies. Then it updates it if they haven't been opened in this version before. It solves the mates. It updates the in-context features and assembly features. So all those little assembly cuts and stuff at the end of your top-level assembly, it's got to do that. And then it's got to do paint display. And then if you've got a drawing, it's got to do a whole bunch of other steps. And then it opens. Okay, so when possible, you want to avoid assembly features. It's really something we don't recommend. When we see assembly features on a feature tree, we're like, oh, it's painful for us to see because we know how much it affects your performance and open times. I know a lot of times in manufacturing, you have to put a couple of components together and then drill a hole through both of them to, ensure alignment and things like that, or avoid alignment issues. And you can still fake that in, and do it at the part level and still show it on a drawing differently. So if you want some recommendations on that, definitely contact your favorite applications engineer. Okay, so how can we open it faster? Let's talk about how we can open the files a little bit better. Okay, so there's a few ways to get some better performance depending on what you want to do. So one thing I will say is a lot of times when we open a file, it's kind of muscle memory. We just kind of double click on the file and open it, and we load everything resolved. But depending on what you're doing, if you just think about, okay, what is it I want to do today? You might choose a different option, and don't rely on that muscle memory. Okay, so so there's lightweight, large assembly mode, large design review mode, and then there's also SpeedPak. So let's talk about these options. So the first and easiest one is lightweight. Lightweight is still giving you a lot of data, a lot of information. It's just not giving you the feature detail. So all the sketches and the features that are kind of packed in that part, it's not loading that detail. But you're still able to, do mates. There's a lot of functions you're able to do, and you can move a lot faster that way. Okay, so lightweight is signaled by this feather icon on your feature tree. It will do it automatically. It will open automatically with lightweight feature, depending on how many parts you have in your assembly. Okay, and then what's interesting to note is when you go to File, Find References, it actually doesn't register those parts are open because they're not fully loaded. Okay, so I think this slide is kind of eye-opening. These are all the functions that you can do in lightweight mode. So as long as you're not, editing a particular feature of a component in an assembly, there's a couple of other things you can't do, but most assembly functions can be done in lightweight mode. Okay, so then there's also large assembly mode, which is kind of like lightweight. So what it does, hang on, let me activate this little pen. So what it does is it's just like lightweight, but it also gives you these, I'm trying really hard to draw a rectangle. Okay, it's trying to give you some additional performance options that you can individually select based on your preference. I think we have an article somewhere explaining what each of these mean, but enabling or disabling some of these will also help with performance. So if you feel like lightweight's not quite enough, go into large assembly mode and play around with some of these settings. And if you want to know more about these settings, just let one of us know. Okay, so large design review, totally different. So when large design review first came out, I don't know, maybe 5 years ago, maybe more, I don't know. It was a big deal because before that, you would go into like a design review with, a bunch of people above your pay grade, and you're like, trying to get into the meeting an hour earlier to load your assembly, and all you're wanting to do is show kind of the progress of your work. And so it was really huge that they came out with this option. You could take measurements and create cross sections and hide and show components and create walkthroughs. If you've not done a walkthrough before, you can do, it's kind of like navigating your design like virtually. So that's a really cool feature. But anyways, so large design review, it's much lighter and much faster than these other options I mentioned. But also they've enhanced it. So you can't do as much editing as you can in like lightweight or large assembly. But it is a lot faster. So depending on what you need, what you actually need to do, it's a good option. Now in 2019, they added some editing capabilities. So you can actually do some simple mates as long as you don't have assembly level features, and as long as all the files are saved in 2019, you can do that because that new functionality was written for 2019 with that code. And then in 2020, they added even more capabilities. You could create component patterns. And those are things that you would do often in an assembly. Okay. You can also open drawings faster. There's something called Quick View. I don't know if you can see that image very well, but you can see that you can open in actually, I don't even know it, but yeah, Quick View, that first option with the little eyeball on it. Quick View is just, it's graphics, it's visual. That's a good way to open drawings. And then new in 2020, there's detailing mode. So you get the same speed out of Quick View, but you can add annotations, dimensions, balloons. So it gives you a lot more flexibility without having to load all the data. Okay, SpeedPak is something I don't see a lot of people using, and it's because I think it's because it's a very abstract concept. So basically, you're creating a configuration of your assembly, and you are choosing what faces or bodies or surfaces are selectable, meaning which ones do you want to access or select for a mate, for example. So you get more control on what is and isn't loaded. So I think this is best illustrated in this image. So you have this, basically this is opening in SpeedPak mode, and the halo, I'm laughing because I cannot maneuver this cursor very well. Anyways, so you see there's some structural members in this assembly, but it's actually not loaded. And you can tell because it's ghosted out here inside the halo. So actually the only thing that's loaded is what the user selected in their SpeedPak. And that is, this surface and that surface. So if you're trying to do some mates in an assembly, you want to think about, okay, which surfaces am I mating to, which edges, and then select those. And just those will be loaded, and everything else is just kind of a phantom, it's just like a ghost of your assembly. So I know that wasn't a great explanation, but I hope it makes more sense, and I hope you're encouraged to at least try it out. Okay, so let's go on to assembly tools. So this is actually my favorite because these tools are pretty powerful. So the first one is performance evaluation. It's on the Evaluate command manager. It used to be called Assembly Expert a few years ago, and it will give you some statistics on your assembly. A lot of the statistics are like how many of your files are still in an older version, how many of them have not been updated, how many levels of assemblies do you have, how deep does your assembly structure go, and all of those things impact performance. So I'm not sure if you can see on your screen. I have one small screen and one large screen, and I cannot see on my small screen, but you can see it tells you how many parts, how many subassemblies, how many circular references do you have. Circular references are bad. But the cool thing is there's these dynamic links in here. Let me draw on the screen. So that if you are interested in knowing more about what you see in this menu, it will kind of give you that data just kind of on an as a needed basis. Okay, so the next tool is assembly visualization. This is really my favorite tool. It gives me a lot of information. It's one of the first things I do when I'm troubleshooting a customer's assembly. Well, there's another one I do, which I'll get to in a second, but so it highlights your problem areas. It does some color coding. It's really a way to find out if you've got like a bad apple in the bunch, you know, like if you've got one part or one subassembly just really dragging your file down. When you go to assembly visualization, it creates this additional tab, and then you can add columns. I think by default, the columns are like quantity, mass, something else that's not useful to me. But if you click on this arrow here, if you click on this arrow here, it will give you some options. It'll say like more, and you click on more, and you can actually add things like, hey, were they converted to the latest version? What's the open time? What's the rebuild time? So you can add all of these columns, and then you can sort them just to see. So most of them are well under a second, but I might see a part that is, 2 seconds for open time or rebuild time. And that tells me, then I'd see a bar way over here and the other bar is much shorter. And that kind of tells me like, hey, something's wrong with this file. We need to fix this. And that could improve, just everything. Okay. And then the other thing is external references. You can right click at the top level assembly, and then there's this item, show update holders. And honestly, I just learned about this, I want to say a year ago. I don't know how long they've had it, but I was like, where did that come from? So I thought that was good. You can get some good information about what's holding it up. Okay, so let's talk about mates and rebuilding. Oh, this is a fun slide to read. This is like a punishment. I'm sorry. Rebuilding. So SolidWorks only rebuilds if something's changed. It's not going to just rebuild everything. Only what it sees as changed. If it's outside of the geometry. So in a collaborative environment where you've got a colleague working on, one assembly, you're working on another, it still recognizes that your colleague has changed that part. Okay. But that rebuild can be influenced by, kind of like we mentioned earlier, in context features and the mates. So this is the rebuild logic. It rebuilds components first, then the mates, then the assembly features, then the in context features. But then remember, I mentioned that loop that you want to avoid. If these in context features relate to the mates or the assembly features relate to the mates, it's got to go back and rebuild that again and do a second pass. Okay. So best practices for mates. Sometimes when we're building an assembly and doing mates, we're not necessarily thinking long-term, we're just kind of mating as we go. But it is good to kind of start with like your main structure, your main component, and then mate the sub-assemblies to it. But you don't want to do any kind of chain-like mates. That will basically lead to a lot of broken mates that you'd have to repair. Okay, like their wording, they said mate scheme to avoid. That's their nice way of saying bad mate scheme. And then of course, circular references, you don't want to do that. That will also create a big mess for you. And then over defining dimensions, you wouldn't put both of these on here. Okay, oh, this image is just painful for me. I don't even know where to begin. Like, we can't have errors on our feature tree. That's bad. We have to fix errors as they appear. So, you know, when someone sends me their assembly and there's like bloodshed on their feature tree, I don't know where to begin, because they've been looking at this assembly for months and I'm looking at it for the first time. I don't know where to begin. The other thing is it's in red, so the moment you get a yellow warning on your feature tree, you kind of have to stop. So the yellow warning means, hey, there's a problem here, but I'm still able to generate the geometry for this feature or this part. So I'll go ahead and do it, but you got to fix this, okay? Red means stop. I am unable to rebuild, or I'm unable to generate some geometry. So, you know, you can't drive through red lights and be surprised that you got in a car crash, right? So we have to get in the habit of fixing the errors as they appear. And I know that's very complicated when you're in a collaborative environment and you're relying on others to have their best practices as well. But just make sure that you guys kind of have kind of a stance as an organization about how to handle warnings and errors. There are some good tips in the help menu on resolving mates. I read something like, hey, sometimes if you just drag a component with a mate error, it'll fix itself. And there's a couple of other tips like that in the help menu, which I thought, I've actually seen that, but I didn't realize it was documented in the help section. So I thought that was cool. Okay, so this is how we feel about feature trees with errors, but hopefully we can attack these one at a time. Okay, so best practice is to build sub-assemblies. You want more sub-assemblies so you have fewer mates, and that will lead to less rebuild time. And then you want fewer flexible sub-assemblies. You know, enable them when you need them, but you can make them rigid and minimize the use of those because those take more compute time. Okay, third-party data. So we actually have a few webinars and recordings that we've done of just importing best practices. That's kind of a topic on its own. But for those of you that did not know, I wanted to talk to you about 3D Interconnect, which allows you to bring in non-native files into SolidWorks. Okay, so 3D Interconnect allows you 3 different workflows. So you're basically keeping the link to the source data intact. It's not being forced to, you're not forcing the data to be part of like a SolidWorks family or code. And then same with the drive part, you do the same thing, but then maybe you add some features or something. Now, prior 2017, really our only option was this. You'd be forced to break the link and then import the data and then, you know, do feature work. So if you're bringing in like a vendor component or something and you're just dropping it into your assembly, you don't need to translate all the data. Just keep it linked. It's a lot easier on your machine if you just keep it linked. And it really just needs to see the envelope and you're designing around it or something. So consider that if you're just working with a vendor partner, you don't need to actually make geometry changes. And then the other thing I wanted to mention on this slide was that if you haven't used FeatureWorks, let me grab the pen. This is the symbol for feature recognition. Feature recognition used to be a professional and premium feature only before 2016, but afterwards it's included in all levels. But if you haven't used it recently, it's super powerful. It works really well for most things. If you have a very like contour organic shape, it's going to struggle a little bit. But you know, if you have like bosses and extrudes and chamfers and revolves, it does great. I've been really impressed with what it can do in recent years. So give it a chance. Okay, image quality and part file recommendations. There are a couple of things that demand more performance. You may not be able to, avoid it necessarily, but just to be aware that patterns consume more performance. Threads, vents, text. When I say text, I mean more like embossed text or what's the word I'm thinking of? Anyways, actual removing material to create text, things like that. Okay, influence of detail. So this is also super important. So this is a simplified fastener, and it's 1,000 triangles to render. Okay, so imagine a massive assembly with all of these. Okay, now this is a fastener with all the thread detail with about 6,000 triangles. Sometimes you need threads. You can't avoid it. If you're 3D printing something that has threads on it, you need the threads. If you're actually manufacturing the threads, then you need to show the threads. But if you're having your manufacturing shop grab a bin item that has threads on it, you don't need to show that on your assembly. It's just costing you performance and time, and you don't need that. Okay, so an example of rebuild time for different features, thread feature versus cosmetic thread, linear patterns, just kind of a snapshot of some stats. Okay, faces, surfaces, textures, demand higher performance, lots of details. So this was a good point my colleague made. So grates, perforated plates, you can actually put a decal of, like diamond plate, for example. You don't need to actually create that geometry. You can just put a diamond plate decal or something. Okay, so this is one of the first things I check. So after I ask where their file is stored, I'm also looking at image quality, not just for the top level assembly, but I kind of spot check some parts. So for a large assembly, you want to keep this slider in the lower third, lower fourth even. I know it's not fun to look at this like faceted shape, but when you're looking at the whole assembly, it's not going to matter. It still understands that it is circular. So it's not going to change anything on your print or anything. And then this is the important thing. If you open your top level assembly, hey, I'm getting better at this. You can select this button, apply to all reference part documents. And then you don't have to do it for every single one. I think that's awesome that you can do that just right from the top level assembly. And if you want to do this as a test, look at your file size, or save and close your assembly and look at your file size and then open it and then bring your slider all the way down here, click on that checkbox and then save it and just look at the file size difference. It can be pretty significant depending on what geometry you have going on. Okay, so low quality versus high quality. So this is just kind of illustrating the difference between that low end slider and the high end slider of this guy. So low quality versus high quality, okay? So you have thousands of triangles to millions. So, it's really about how much you need. So low quality, I think, is better when you're talking about this many components. Okay, so geometry pattern, I really didn't know where to fit this in my presentation, but it's important to mention. If you've got a pattern, make sure you choose a geometry pattern. So when you have this option cleared, when you don't check geometry pattern, what it's doing is it's recalculating it over and over again. It's calculating with your end condition. It's kind of redoing the math for each single component. But if you just want to hollow out your part with the same amount of volume in whatever spots you want, it ignores the end condition and it copies that exact geometry. It's a lot faster. You'll definitely see a file size difference with geometry pattern. Okay. So that summarizes large assembly best practices. There is a lot we didn't talk about. This could be a whole day's worth of material. I have a few important slides to show you. Please feel comfortable submitting feedback. And then if you'd like to participate, you can submit an answer on Twitter and tag GoEngineer, and just make sure you use this hashtag. It's just pretty simple. How are you making the most of your time during the quarantine? And we have 3 $25 gift cards. We'll mail them to you. I thought that would be kind of fun. And then don't miss the next webinar, CSWA and CSWP benefits, presented by Tim Strange, who has an awesome radio voice. So it's really important that these, that you know about these certifications, because it's really important to not just the users, but managers and just your whole organization, how it reflects on you guys. Tim is also the voice behind the self-paced advanced classes, and advanced parts and advanced assemblies. So, so that should be a good one to catch. And then just a reminder of our design from home options. Thank you so much for joining us in this weird time. Keep in touch. I appreciate it.